Now tomorrow we have a quiz. We're only gonna cover 2-3 sections here. So trig, quiz. Well, I don't even see you on Monday. Hello. I was falling right into your web of deception. Huh?
Tuesday.
No. The test is next Wednesday already.
Yeah, we'll just have quiz and test.
Yeah, wait, is there a practice quiz?
No, there is none. However, this morning, this morning I came to school 6 o'clock just to make you guys practice test. So if you wanna practice for tomorrow's quiz, just do the first page of the practice test. It will be posted after lunch today. It'll be almost exactly. So what do you have to know for tomorrow's quiz? You gotta know, well, last night's homework, SOHCAHTOA, and then what did we learn the night before?
K equals something.
The arc length, here, this is what's gonna, S equals r theta, area equals 1/2 r squared theta. That's what you gotta know on the quiz. Plus SOHCAHTOA, last night's homework. But you gotta remember, when you use these formulas, theta gotta be measured in radians now. So if it's not radians, you gotta convert it to radians.
It's just pi over 180.
Yeah, just, so if it's degrees, just multiply it by pi over 180. Yes. It's easy. Okay, what problems do we need to go over today? Go.
21.
21.
23.
23.
27.
27. 29.
31.
That's like all.
37.
35.
33.
What was the assignment?
We didn't.
13 through 37. So all I don't have to do is 13 and 17.
And 29.
Maybe 25. Can you actually be looking at 17?
What?
What?
You cannot ask if you didn't even try.
I did do it.
Okay, so do we need to do 13 and 17?
I was just kidding so
No.
far.
Oh, look at that.
I was just kidding.
Okay. No such thing. Okay, so in a right, so this is number 21 we're doing. Okay, so in a right triangle, what is the picture they give you? They give you like this. This is A, this is B, this is C, which means of course, this is A, B, and C. So in problem 21, they said A is 2, C is 5. Find B, A, and B. That's because we already know angle C is 90 degrees already. We don't have to do anything. You know what? Let me get my calculator. So I'll just keep it in my pocket. Because we're making the answers for the solutions for the practice test. I have to use calculator on every problem. That's what you guys are going to have to do. So yeah, for tomorrow's quiz, you got to bring calculator.
Oh, I did have a calculator in my bag.
So look, let's do the easy one first. If A is 2 and C is 5, how do I figure out what B is? How do you use the Pythagorean Theorem, right? B squared plus 2 squared equals 5 squared. B squared plus 4 equals 25. B squared is equal to 21. B equals radical 21. And you can punch that in on your calculator if you need to. Okay, now how do you find angle A up here? Well, you already know all three sides, so you can use sine, cosine, or tangent. It doesn't matter. But I don't like punching in radical 21 on my calculator. So you know what I do? I'm just going to use these two sides because they're nice. Yeah. So if I want to find this angle, what is this side? This is opposite. This one is the hypotenuse. So which of the three has opposite and hypotenuse in it?
Sine.
Sine. So the sine of angle A is equal to opposite over hypotenuse. Okay, now, how do you figure out angle A? We did this last chapter. How do you find the angle that corresponds to this? What do you punch in on your calculator? Sine inverse 2/5. So that's what you punch in on your calculator. So let's assume that do they want degrees? They want degrees, right? Yeah, everything is degrees, so they want degrees. So put your calculator into degree mode, which it is. And so I just go sine, oh you dummy, sine inverse 2 divided by 5. Woo! So I get 23.578 degrees. You're gonna have to round out to 3 decimal places. Now, if the book says 2, then you can just get 2, but on my quizzes and tests, it's gonna say 3, so you're gonna. And then of course, how do you figure out B? Do I have to go, okay, here's this angle, this is adjacent, this is hypotenuse, so I'm gonna use cosine, right? So the cosine of angle B is equal to adjacent over hypotenuse. So how do I figure out B on my calculator? What do you do? Cosine inverse 2/5. Now, you can do that if you want, but come on. If this is a right angle right here, then shouldn't these two add up to 90? So once you get this one, just subtract that from 90. So once you, now if you have a regular scientific calculator, I don't, how do you guys do that? Like see, if you have a graphing calculator, you have this button. Sure, look for this button if you have a regular scientific calculator. Do you have that answer? Now, graphic calculators have it, right? But I'm talking about regular scientific calculators. You guys have it? You know what this is? This is the last thing that was computed. So since this is the last thing I computed, all I have to tell my calculator is go 90 minus answer. Instead of writing it down and you know what I mean? So 90 minus answer. Oh, and you get 66.422 degrees. Or whatever you see here, just go 90 minus that and you get your answer. Or you can do this too. They all can come out the same. Okay, we got a lot of problems to do, people. 23. Are you guys practicing with your calculator? Okay, now the word problems. No! The hypotenuse, okay, so draw a right triangle. The hypotenuse of a right triangle is 5. One leg is 2. That's the same thing as this. Find the measurement of each angle. Come on! We did it already. Okay, but I'll do it again. You know what, I'm not gonna do it. This is like census. We did it right here. Here's your 2 answers right there. There's the 2 answers. Come on, that's an insult to your loins.
What?
To your loins. 25. You know, like, never mind. 25. Find the angle of elevation of the sun. Okay, here we go. At 10 a.m. on April 26, 2006, a building 300 feet high cast a shadow, so the sun shines, so here's the shadow, 50 feet long, except this picture is not drawn to scale, obviously. What is the angle of elevation of the sun, right there? So there's the picture right there. So here's the angle that you want to find. You guys remember, angle of elevation is measured from the horizontal going upward, yeah? So this is the opposite side, this is the adjacent. Which of the trig functions has opposite and adjacent in it? Okay, you know what? Some of you, write this down on your paper. So, ka, to, a. Which one of these 3 has opposite and adjacent in it? Like right there. Okay, so I'm going to use tangent. The tangent of this angle that I'm trying to find is opposite over adjacent, which comes out to 6. So how do I find this angle on my calculator? What do I have to punch in to find the angle? Tan inverse 6. So you take out your calculator and you go tan inverse 6. Woo! And I get 80.538 degrees. Now, if you want to impress me, no, you can just leave your answer like that. But if you want to impress me, remember I told you on your calculator, you have this button here, degrees, minutes, and seconds. Once you get this on the calculator, if you press this button, it'll convert it to degrees, minutes, and seconds. So I have that button on my calculator. If you have this calculator, it's in the angle menu. You go to angle, and then look at number 4. Number 4 says convert to degrees, minutes, and seconds. Some of you might have this instead. That's degrees, minutes, and seconds. So it's either that button or that button. So I select that, boom, and it converts it for me. 80 degrees, 32 minutes, and 16 seconds if you round it up to the whole second. But you don't have to do that. You You can just leave your answer like that, that's fine. Just read what you see on the calculator. Okay, look, how come we're doing this problem? Now, tomorrow's quiz, I'm gonna give you the picture. There won't even be any word problems tomorrow, okay? I'm just gonna give you this picture, I'll say compute that angle, you guys can do that, yeah? Except I'm only gonna use single digit numbers like 5 and 2 or something. Okay. I think you guys can handle that, okay? Okay, 27. 27. Finding the speed of a truck. Okay. Look, they gave you the picture! A state trooper is hidden 30 feet from a highway. That's 30 feet. 1 second after a truck passes, the angle theta, where is theta? This angle here, theta, between the highway and the line of observation of the patrol car is measured. See illustration. A, if the angle measures 15 degrees, how fast is the truck traveling? So what we need to do is, we need to figure out that. Okay? So this is the distance the truck travels in 1 second. Okay? So how do I find x? Well, here's the angle. Opposite, adjacent. Which of the three has opposite and adjacent in it? Tangent. So the tangent of 15 degrees is equal to opposite over adjacent. Can I solve for x? Yes, multiply both sides by x to get this. And then divide. Hopefully after doing several of these, you can go straight from here to here. But you gotta actually do it. Then you take out your calculator and you punch it in. Make sure you're in degree mode now. 30 divided by the tangent of 15 degrees. Woo! I get 111.962. Did you guys get that? And is that all you have to find? No. It says, how fast is the truck traveling? Express the answer in feet per second and in miles per hour. So we're going to have to do dimensional analysis. Now, is this all feet given? Yeah, it's all feet. So if it traveled this much feet in 1 second, then what was its speed in feet per second? Divide that by 1 second. Yeah, that's the answer. It's that feet per second. So it's going 111.962 feet per second. Now, most people don't understand that. Is that fast or is that slow? Most people understand miles per hour. So what we're going to do now is we're going to convert to miles per hour. So let's do some dimensional analysis. Let's take care of the time. So if I want to get rid of seconds, you got to put the seconds on the top so you can cancel it. Put the hour on the bottom. And then what do we know? 1 hour is how many seconds? You guys told me yesterday. 3,600 seconds. And if you're taking physics X here, this will help you. See, seconds cancel out. So now we got feet per hour, but they want miles per hour. So if I want to get rid of this feet, you got to put the feet in the bottom and the miles on the top. But we know that 1 mile is equal to 5,280 feet. See, the feet cancel feet, and all you're left with is miles per hour. So if you want to convert from feet to seconds to miles per hour, you simply multiply by 3,600 and divide by 5,280. So once you get this number on your screen, you multiply by 3,600 and you divide that by 5,280, and I get 76.338 miles per hour. On an average highway on the mainland, it's just nothing. Yeah? It's nothing. Mm-hmm.
Like when I type in tangent 15 degrees on my calculator, it's 2 minus root 3.
Yeah, that's the exact value.
So then how do I like get the decimal?
No, he is in degree 1. What about 30 divided by that?
Yeah, it says it's 60 plus 30 root 3.
Oh, so we need a decimal answer. That's a good question. I don't know. Where is that? Oh, he doesn't have the, I don't think you have the button. Like on the old, no. You know what, I'll Google it after then.
Oh, here I found it.
What is it?
You press the fraction to decimal.
Oh, okay. Okay, so in problem B, what if the angle is 20 degrees? What if this angle was 20 degrees instead? Well, duh, then just change that to 20 degrees and you're gonna get the same problem. You guys can do that, right? And then part C, if the speed limit is 55 miles per hour and a speeding ticket is issued for speeds of 5 miles per hour or more over the speed limit, for what angle should the trooper issue a ticket? Well, for this angle, if it's 15 degrees, you're gonna get a ticket.
But isn't that still?
Why? It says 55 miles an hour.
No, but if they were to give it, if it was like
5 miles an hour over. But you're gonna argue with the book. Okay, don't worry. Okay, tomorrow's quiz, you're just gonna have this picture. That's 20 degrees. Can you find x? Okay. You don't, no word problems tomorrow. I just want to see if you can do SOHCAHTOA and those two formulas that went over the board. It'll be easy. We don't need a practice quiz. But if you want to, it'll be online. Just the first page of the practice test. Okay, did I erase the problems too? That's dumb. What's the next problem? 29. Finding the bearing of an aircraft. A DC-9 aircraft leaves the airport whose bearing is okay, first of all, before we even do anything, do you guys even know what this is? From the north, you measure off 40 degrees east. Okay, let's pretend you don't know what that is. I bet you if you looked in the reading before, does it tell you? Let's look. There you go. It's right there. So, because you only take a picture of this part of the book, yeah? Okay, so from the north, so here's north. You guys know what north is, right? From the north, you go 40 degrees east. So this is the direction. See, 40 degrees, like that. Okay, so a DC-9 aircraft leaves the airport, and it's going like this. It flies for half a mile, so half a mile. The pilot requests permission to turn 90 degrees and head toward the southeast. So from here, you turn 90 degrees like that. That's a 90-degree angle. The permission is granted after an airplane goes 1 mile, so it's going to be 1 mile. What bearing should the control tower use to locate the aircraft? In other words, so here's the airport right there. They want to know, you got to know this angle right there. That's what you got to figure out. Okay, now, look, once I draw a picture, this is so easy. Look, if this is the right triangle, this is the angle I want to find. This is the opposite side, this is adjacent. Which of the three has opposite and adjacent in it? Tangent. Tangent of this angle is equal to opposite over adjacent, which is 2. So if you do that on the calculator, you should get like 63 point something degrees, yeah? Okay, I'll do it. Tan inverse 2. Here. Tan inverse 2. Let's see if I'm right. Tan inverse 2. Whoo! See? 63.435 degrees. That's what this angle is. However, you got to answer the question. The question is asking, after the airplane goes 1 mile, what bearing should the control tower use to locate the aircraft? So, we know this entire angle is this, but you got to give something that looks like this. You got to give a bearing. So what you got to do is you got to draw in the horizontal right here, like that. That's the horizontal. If this angle is 40 degrees there, what is this one there? Since that makes a right angle here. Wouldn't that be 50? And if this whole angle is this, 63 point something degrees, and this is 50, what is this one right here? Because this one and this one got to add up to 63, so what does this one have to be? 50 plus this got to equal that. 13.435 degrees. So how do you give that as a bearing? What direction is this right here? What direction is that? Okay, here's north. What is this? This is east. From the east, you go 13.435 degrees. Which direction? south. See, you guys can do this, but then you gotta put it together in a word problem. Anowina? Huh?
Wait,
Kim?
I think the answer is like 73.8 something.
Yeah. From the south, you go 70, not, how can it be 70? 76.565 degrees. From the south, you go east, like that then.
Oh yeah, that was mine.
That's the same thing.
Well, that's not what it said.
What? Just look. You can either measure from the south and go east, right? Then this would be the answer. Or you can measure it from the east and you go south. Right? Well, either one of those is correct. It doesn't matter. So what are you guys telling me? You guys can struggle with the word problems, huh? Oh gosh.
Yes.
Well, luckily for you, no word problems tomorrow. But on the test, get word problems. Oh! Ah! 31. Niagara Falls Incline Railway, situated between Portage Road and Niagara Parkway, directly across from the Canadian. That's all filler stuff. Railway is a funicular that carries passengers up an embankment to Table Rock Observation Point. See, that's all filler. You just gotta. So what you want to do? There's an embankment that goes up to something like that. The length of the track is 51.8 meters. And the angle of inclination is 36.2 degrees. Determine the height of the embankment. Okay, so if you just get rid of all the words, that's what you're gonna find. Can do? See, so this is like tomorrow's quiz. Find h. Except I'm not gonna even give meters tomorrow. It's gonna look like that. Okay, so here's the angle. I'm trying to find the opposite side, and this is the hypotenuse. Which of the trig things has opposite and hypotenuse in it? Sine. The sine of 36.2 degrees is equal to opposite over hypotenuse. How do I find h? Multiply both sides by 51.8. So h is equal to 51.8 times the sine of 36.2 degrees. Punch that in on your calculator. Now, on tomorrow's quiz, you write this. I think there's going to be 5 problems, 4 points each. You write this down on your paper, you get 2 points, and you got to be able to punch it in on the calculator now. So 51.8 to get the other 2 points times sine of 36.2, 30.593 meters would be the answer. Now tomorrow there's no units, so you just write 30.593. So as long as I can translate these things for you, you guys can do it. That's so sad. 33. Chicago skyscrapers. The angle of inclination from the base of the John Hancock Center to the top of the main structure is approximately 10.3 degrees. So we got a structure basically, so they're saying 10.3 degrees is the angle of inclination. If the main structure of the Sears Tower is 1451 feet tall, how far apart are the 2 skyscrapers? So they want you to find out the distance between the 2 buildings. So you gotta, how come you guys can't, no, never mind. Okay, look, so here's the angle, that's opposite, that's adjacent, so what? Which of the trig functions has opposite and adjacent in it? Tangent. So the tangent of 10.3 degrees is equal to opposite over adjacent. Now, can you guys just do this? X equals 1451 over tangent 10.3. Can or cannot?
Possibly.
Or do you have to multiply by the x first and then divide by the tangent? Whatever, you gotta get there sooner or later. So you write that on your paper, you get 2 points. You want the other 2 points, you gotta punch it in on the calculator. 1451. The only difference tomorrow is that, no, I'm not going to give 4 figures, this will be like 5 or something. 1451 divided by tangent of 10.3 degrees, kaboosh, 7984.337. Now what was this, feet or meters? Don't worry, tomorrow it's just units, so you don't even have to worry. Okay, 35, let's finish this up. Good thing today's lesson is easy. Finding the pitch of a roof. Look, they give you a picture. I don't have to draw the picture's right there. A carpenter is, I can't even read this, my eyes are so bad. A carpenter is preparing to put a roof on a garage that is 20 by 20 by 40 by, a steel support beam 46 feet in length is positioned in the center of the garage. Okay. To support the roof, another beam will be attached to the top of the center beam. At what angle of elevation is the new beam? Are you serious? So, if you just sift away all the information, this is the angle they want you to find right there. Okay? Do they tell you what this is right here? Right there. Do they tell you what that is? Okay, you know what? You guys are going to have to do something. Chun, look at the picture. Tell me what that is.
I see the book.
No! What? Is that -1 after quarter average?
Hey,
I told you, you guys better have the picture if you did the do. Yamashita? Thank you.
Stand.
And then, Chun, second chance. What is this?
It's 20.
Whoa. Chi? Okay, if Chun doesn't bring it, okay, that's normal. But if Chi doesn't bring it, that's not normal. Pan? Okay, 26. Okay, so I'm trying to find this angle. This is the opposite side, this is the adjacent side. Which one has the opposite and adjacent in it? Tangent. Tangent of the angle is opposite over adjacent, which is, if you want to simplify it, 2.6. So how do you find that angle? Tan inverse 2.6. Okay, let me try to do this without a calculator. We just did tan inverse 2 over here, yeah? 63, so it's going to be bigger than that. So, but it can't be bigger than 74, 2. So my guess would be 2.6, 68?
69.
I'm just guessing. Tan inverse 2.6, 60? Ah, pretty close. 68.962 degrees.
So 69
Yeah,
degrees.
I was off by 1 degree. Without a calculator. That's pretty darn good, I'd say. And then finally, 37. In geometry. Okay, you know what? I was wondering if I should even assign this problem. Do you guys even remember any geometry? I was thinking, should I assign this problem? But I said, you know what? I think I should. But maybe, and because they give you the picture. This is 2. Okay, now remember, you guys remember this, right? If you have a circle and then a tangent line, when you draw the radius to the point of tangency, it makes a right angle like that. You got to know that on the ACT and SAT, right? So it makes a right angle like that. Same thing here. This is the center of the circle. You draw the thing to the, and you're going to get a right angle there. So this is 2 and this is 4, and then you got right triangles. Get 2 of them. Now what's the question? Find the angle to the nearest tenth of a degree. Well, we're going to give 3 decimal places. So they want you to find this entire angle right there. So what do? You find this angle here, and then you double it. In fact, because theta, they call theta the whole angle. So what do we call this half, the alpha? So what you do is you find this angle, and then you just double it to find the whole thing, right? Because remember, you can only use SOHCAHTOA on right triangles. So you got to make right triangles. Yo, Mr. Park, what do I want to do? I don't even know anything. Well, come on. This is 2. Isn't this the radius of the circle? This is 2. So isn't this 2 going to be? That's 2. And the radius of the circle is 4, so that's 4. Isn't that 4? Now, do they even give us any other information? No, we don't. That's it. That's all we know. We don't even know what this is. Do we even have to know what that is? Wait. Oh, look at this. What if you drew this in like this? From here, you go like this. And you make a rectangle right here. See, this is a rectangle. would you agree? So that means, look, look. See, that's what, you guys see that? Rectangle right there? We do this in the math team all the time, so there's a right. So what you wanna do is you wanna look at this right triangle right there.
2.
So would you agree that this angle here, right there, is the same as that angle right there?
Yeah.
Okay, so all you gotta do is just find this, but then look, we know this is 6, right? That's 2 plus 4. What is this?
2.
2. So, here, let me just boil it down again for you. Don't worry, you're probably not gonna see it. This is 2, this is 6. How do I find that angle there? So just boil it down for you. That's what tomorrow's quiz looks like. So this is opposite and hypotenuse. Which of the three has opposite and hypotenuse in it? Sine. The sine of this angle is equal to opposite over hypotenuse, which is 1/3. So theta is equal to sine inverse 1/3. So you take out your calculator. Wait, let me try and guess this one. Shh. No, 0.8. No, I'm trying to do that.
What's wrong?
2.8. 20, 19, 20 degrees? Don't tell me wrong. Sine inverse, oh wait, we missed it. Sine inverse 1/3. 19!
I didn't say anything.
Who told me that was wrong?
I know.
We know.
19.471 degrees. But you gotta remember, this angle here is half of the one they want you to find. So you gotta times that by 2. So times it by 2, and your final answer is 38.942 degrees. Goosh. See? 19. I nailed it. Telling me I'm wrong. I'll give you wrong. Okay, so do you guys understand what tomorrow's quiz is? It's just like this. You don't have to read any words. It's gonna be pictures. You just gotta pick the right one, sine, cosine, or tangent, right? And it looks like you guys can, right? But then you gotta prove to me that you can punch the stuff in your calculator.
Wait, and then the test is on the quiz and then what we're doing today.
Yeah. Okay, you know what, since we did this already, so this one, you're gonna have 4 of these problems tomorrow. The first problem here, I'll just show you. Here's your practice quiz. You wanna practice quiz? Okay, so like, let's say this is 1.5 radians. Now, if I don't put the degree sign on there, that means it's radians now. That's 1.5 radians. And what do you wanna call the radius of the circle? Give me a number.
10.
Okay, 10. Okay, so number 1 on tomorrow's quiz, find the arc length and the area of the sector. Okay, this is number 1. Okay, how do you find arc length? What's the formula?
Theta.
R times theta. So what's the radius of the circle?
10.
10. What's the angle that's measured in radians? 1.5, so your final answer? 15. You don't even need a calculator for that. Now, how do you find the area of the sector? What's the formula?
R
1/2 r squared theta. So 1/2, what's the radius?
10.
10 squared times the angle measured in radians, 1.5. That's your answer. So what is that? 1/2 times 100 times 1.5,
75.
75.
Do that in slippers.
Yeah, but Mr. Park, tomorrow you're going to give us degrees, I bet, over there. No, I'm not. I'm giving it to you in radians. Okay, so there's the quiz. Can you guys do it? I just told you everything. Okay, now what is tonight's homework? Tonight we compute areas of triangles. Sorry to bore you.
No. That wasn't a yawn.
That wasn't yawn. You guys are kidding me. Okay, let's review something from geometry. If you know 3 sides of a triangle, did we learn how to compute the area of a triangle? This is geometry now.
1/2.
Now, this doesn't have to be a right triangle, Steve. Because if it's a right, come on, if you just think about it. if you have a right triangle, for example, 3, 4, 5, you don't even need the hypotenuse. How do you compute the area of a triangle? 1/2 base times height, finished, right? It's a right triangle. So, but what happens if the triangle is not a right triangle? Like something like this, you just give it any 3 sides. How do you find the area? We use somebody from geometry, we use somebody's formula. Blank's formula. Pythagorean's formula? No.
Michael Parks.
No! Heron's formula. Heron of Alexandria. You guys ever watched, what's the thing, Imhotep?
Oh, Mummy.
The mummy.
The Mummy.
Is that in Greek? That's not even Greek yet. Okay, never mind. Anyway, you guys, yes or no? Did you guys hear of Heron's formula from geometry? Yeah. Okay, so the Greeks knew, because you know what they used this for? You know why trigonometry is invented, the study of triangles? So that when you have triangular plots of land, then you can compute the area, right? Because then you're going to pay taxes on it. Yeah, but Mr. Park, what if the land is like a quadrilateral? Then you just break it up into 2 triangles, right? See, no matter what kind of land you got, like what if it's that? Then you just break it up into triangles, right? Why are you laughing? No, it was boring before, but now it's exciting. Okay, so what is Heron's formula? Okay, I'll tell you. The area, if you're given 3 sides of a triangle, the area is equal to the square root of s times s minus a times s minus b times s minus c. Does this formula look familiar? You don't? Does it look familiar? Like, you've never seen this before?
No.
Are you serious? This is geometry! Oh my god. Okay, A, B, and C are the sides of the triangle, but Mr. Park, what is this S business? What is that? Somebody? Yamashita? Chi. Pan? Chi. Izuo? No? So don't even bother going to that side of the room.
That's the side.
Triangle.
No, it's the semi-perimeter of the triangle. S stands for semi-perimeter. So, what is the perimeter of this triangle?
ABC.
No, A plus B plus C. Perimeter, but semi divided by 2. Semi-perimeter is half the, you know semi means half, right? Like semi-circle. Semi-sweet means half sweet, right? Semi-perimeter is half the perimeter. Okay, this is called Heron's formula. This is how you compute the area of a triangle if you know all 3 sides. So let's do an example. There's only 2 examples today. Like I said, it's going to be easy. Okay, give me 3 sides. Any 3 sides?
4, 5, 6.
4, 5, 6. Okay, let's go. 4, 5, 6. Good choice. Compute the area of this triangle. First thing you do is you compute the semi-perimeter. What is 4 plus 5 plus 6 divided by 2? Go. 7.5. Everybody can do that? 15 divided by 2? Okay, now it just depends. If you get to use your calculator, then it doesn't matter. But if you're not using your calculator, then I would not use 7.5. I would use 15 over 2. So you tell me, you want to use your calculator or?
Calculator.
No, I don't want. I want the exact number. We're not going to use calculator for this. So here we go. I'm going to use 15 over 2. So according to Heron of Alexandria, the area of this triangle is the square root of the semi-perimeter. Right? Just follow this formula. And then all you got to do is go s minus a, s minus b, s minus c. Just keep subtracting the sides. So 15 over 2 minus the first side, 4. 15 over 2 minus the next side, 5. And then 15 over 2 minus the other side. Bam! That's it. You write that on your paper, you're going to get, should I say 4 out of 5? No, because you got to do plenty of computations. Now, if you have a calculator, then that would give you 4 out of 5 points. But if I'm not going to let you use a calculator, that would be 3 out of 5 points. Now, we're going to compute this baby. This is not hard. Okay, 15 over 2 minus 4. Now, obviously, you want to make a least common denominator, so 4 is 8 over 2, right? So what do you get? 7 over 2. So you guys can do it. 5 is 10 over 2, so if you subtract, you get 5 over 2. And finally, 6 is 12 over 2, so subtract 3 over 2. See, now it's all coming together. So what do we got? If I multiply out the denominator, what is 2 times 2 times 2 times 2? 16, square root it? 4. So the denominator is just 4. That's easy enough. Now what about the top? Do I really want to multiply out these numbers? No, because look, this is 15, that's 15. What is 15 squared? You don't need to know that because if you have 15 squared, what happens when you square root it?
1 gets
No. You get 15, okay.
15.
Thank you. Thank you, it's 15.
That's what I said, 1 gets cancelled out.
That's not what you said.
That's what
There
I
you
said.
go, boom, without a calculator, that's the answer.
That's what I said.
But you know what, just observing just what happened here, you know what? I'm just gonna let you use your calculator. So, if you have a calculator, this is what you punch in on your calculator. I would use the 7.5 because it's faster to punch in than 15 over 2, yeah? So, just go 7.5 times 7.5 minus 4 times 7.5 minus 5 and then 7.5 minus 6. Boom! Okay, you practiced it. So, square root of, I'm trying to concentrate here. Shh! I'm trying to concentrate. 7.5 minus 4. 7.5 minus 5. 7.5 minus 6. I get 9.922. I think it was more fun without the calculator. That's what I thought. Okay, so if you are given 3 sides of a triangle, you use Huron's. I cannot believe you guys didn't learn this in geometry. You know what? I'm going to go see the geometry teachers at lunch today. I'm going to ask them if they teach them. I want to know the truth. Okay, I'm going to erase now. So, the last thing we're going to learn today is, what if you have something that's not a right triangle, and you know 2 sides and the included angle over here. So, give me something. Give me 2 lengths. 3, 4, and give me an angle measurement.
50.
No, that doesn't look like 50. How about 97.3 degrees then? Huh? What? Okay, now, how do you compute the area of a triangle if you know 2 sides and the included angle? In other words, the angle in between those 2 sides. Now, I'm going to derive this for, I'm going to erase this. I'm going to derive it for you. Because you don't want to just know the formula, right?
No.
Okay, suppose you have a triangle. You know 2 sides and the included angle. What is this angle? This is A and B. What angle is this? Is it capital A, capital B, or capital C?
Capital B.
Oh, no. What do we learn? If you have the side here, angle A is opposite from it, right? This is side B. Angle B is opposite from it, so what's left?
C.
It's C. Okay, there you go. So, if you know 2 sides and the included angle, how do you find the area of a triangle? Well, isn't area of a triangle 1/2 base times height? Yes. Now, what if we consider this to be the base of the triangle? Okay. Then wouldn't the height be right here? Okay, now, how do I compute this height? What do I do? Well, this is last night's homework. Look, I know this angle. I know this is the hypotenuse. How do I find this, the height, which is the opposite side? Look, you have an angle, opposite and hypotenuse. Which of the 3 has opposite and hypotenuse in it? Sine. The sine of angle C is equal to opposite over hypotenuse. So therefore, what is H equal to? Multiply by A sine C. So the height of this right triangle is A sine C. Put it all together, what do you got? 1/2 AB sine C. Boom, I'm gonna box that. So, this is the formula you gotta know for tonight's homework. So, if you know two sides and the included angle, that's the fastest way to find the area of a triangle. Now, depending on what letters you use, like the book, I'm pretty sure your book, like, that's all you really need to know. But your book might write this. What if the two sides are given are B and C, then what angle do you put here? Like if that was B and C, what angle would be in between it? A, that's right. And then, what about 1/2 AC? What angle would be in between A and C? It would be B. So, yeah, so the book might give you all three of these formulas, but you really only need to know one. It's 1/2, the product of the two sides, times the sine of the angle that's in between them. So the fastest way to find the area of this triangle is 1/2 AB times the sine of that angle, 97.3 degrees. And just punch that in on your calculator. Okay, so let's do it. So make sure your calculator's in degree mode, and it should be, so you punch this in. Boop, 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 boop. I get 5.951 square units. This is an area now, so it's square units. So can do. So there's only two kinds of problems you're gonna get tonight. Either you're gonna know all three sides, then you use Heron's formula, or you're gonna be given two sides and an angle in between it. Okay, here's a problem. Okay, this is a circle now. Whoop, whoop, give me an angle. No, let's do radians. 1 radian. And then, what do you want to call the radius of the circle?
5.
5, okay. Find the area. No! Let's do something more interesting. Find the area of this region.
What?
Yeah! Now we're talking. Okay, we do this problem.
What?
Okay, you know what? You want me to, let's just do degrees then. 80 degrees then. Find the area of this region. Okay, now I know you guys learned this in geometry. If you have a sector of a circle, and then you draw this chord in right here, what is this region here called? There's a name for it. Bonus point, right here. There's a name for this shaded region here. Who had Mr. Masunaga?
For.
Okay, no,
No.
because I know Mr. Masunaga teaches this.
Mm.
This region is called a
Sector.
no
Segment.
Very good. Too late, but didn't that?
Bonus.
It's called a. No, you didn't get it without the hint. So find the area of this segment of a circle. Now, some of you are thinking, Mr. Park, isn't a segment like that? Yeah, that's a segment of a line, though. This is a segment of a circle. Okay. How do you find the area of the shaded region? Well, what do you know? Do I know how to find the area of a sector? Yeah, that's going to be at tomorrow's quiz. Do I know how to find the area of a triangle? Yeah, we just learned that. So, how do I find the area of the shaded region? Wouldn't it be the sector minus the triangle? Yeah, so that's how we do it. So, we're going to compute the area of the sector, and then we're going to minus the area of the triangle. Okay, now how to find the area of a sector? What is the formula we got to know tomorrow? Area of a sector is what? 1/2. This is tomorrow, people, you got to know this. R squared theta, but the angle got to be measured in radians. So the area of a sector is 1/2. Now what is the radius of the circle? Look, it's written right there, 5 squared